Hello everyone, myself Dr. N. Srinivas, Professor and Head of the EC Department. I've been working for 10 years in this institution and today I am here to discuss the Module 2 of Hardware and Software Co-Design. This is a course we are teaching to MTech second semester students, and especially today we are discussing Module 2, Prototyping and Emulations. So as I mentioned in the previous lecture, so this is the syllabus, hardware and software co-design. This is a professional uh, elective, that is program elective 3, and it is for first year MTech second semester. And as we know, course overview, as I said earlier, this course provides a comprehensive understanding of hardware software co-design principles used in embedded systems and system on chip development. It covers methodologies for partitioning system functionality between hardware and software, exploring trade-offs in performance, cost, and power. Students will learn co-design techniques, system specification models, co-simulation, co-verification, and modern design flows used in real-time embedded applications. So the prerequisite for this course: digital system design, microprocessors, and microcontrollers. So these are the course objectives and the course outcomes. As I said in the previous lecture, the second outcome gives the outcome of course outcome of module 2, that is analyze the system requirements and perform hardware software partitioning effectively. This is the outcome we are going to discuss in detail of module 2, that is the prototyping and emulation. So this is a unit 2, that is module 2, prototyping and emulation, and it consists of several topics in this module 2: prototyping techniques, emulation techniques, prototyping and emulation environments, future developments, architecture specialization techniques, system communication infrastructure. These are the topics we are going to cover today in module 2, that is prototyping and emulation. So what is prototyping? Now we are discussing introduction to prototyping and emulation. So what is prototyping? So process of building an early working model of an embedded system is nothing but a prototype. So it is used to validate design functionality before final implementation. So before final implementation, first we design the prototype and we check what is the functionalities and its working operation and its application. So after that, it helps to detect design errors also at an early stage. That is nothing but prototyping. So what is emulation? Emulation is a technique that imitates the behavior of the target hardware. So targeting hardware behavior, technique, it is a technique that imitates. Okay. So also it allows software testing without the actual hardware. That is nothing but emulation, and it is used for debugging and performance analysis. So in prototype, it helps the detect design errors at early stage, and this emulation is used for debugging and performance analysis. So the key difference between this prototyping and this emulation: this is a prototyping means nothing but real hardware implementation, and emulation means a hardware behavior simulation. So that is both are that is the difference. And prototyping used for design validation. It is used for software testing and debugging, because we are discussing hardware software co-design. So definitely in order to perform hardware, so there must be a simulation, okay, testing and verification and debugging, so that both hardware and software can be performed together. So that is the topic today: prototyping and emulation. So there are prototyping techniques. So these are the common techniques are breadboard prototyping, because it is a low cost, suitable for simple circuits. So if you have components, then if you know the circuit, if you know the application, then we can use this breadboard, and we can interconnect all the components, then we can test what is our hardware. So then we can perform the this one. So PCB prototyping is another common technique for this prototyping technique. So it can be used if you can use PCB for designing any hardware. I mean simple circuits if you want to design, and using this PCB prototyping you can see better performance used for advanced embedded systems. So here definitely we use PCB prototyping. This is the common second technique. And FPGA based prototyping, this is a high speed reconfigurable hardware and suitable for ASIC verification. So here this is a third type is FPGA based prototyping, and fourth one is a rapid prototyping. So that is quick development using development boards. Okay, example Arduino, Raspberry Pi, STM32. So these are already existing microcontrollers, and with the help of these development boards, so we can quickly develop one prototype. That is the fourth type of prototyping. And finally, the advantages of these prototyping techniques, we can develop faster development for any application. It reduced design risk and early testing. So these are the common techniques we are discussing. Breadboard prototyping. In this case, we use breadboards. If you are using PCB case, that is a PCB prototype. FPGA based means it is a high speed and reconfigurable hardware case. We use that. And rapid prototyping case, already Raspberry Pi, Arduino, STM32 are available. With the help of them, we can design any application. So that is one type of prototyping is called rapid prototyping. These are the advantages. And emulation techniques. So here types of emulations. In circuit emulations, that is ICE, in circuit emulation, software emulation. So as I told you, emulation is helping to debug or testing the softwares implementations. Okay, so here these are the in the previous slide we have seen prototyping techniques. This is the emulation techniques. So it is pure related to software. So here in circuit emulation means connected directly to the target hardware. So whatever we want to use that software, so that will be directly connected to the hardware, and supports debugging and monitoring. So software emulation, so here runs hardware models on a computer, and it is low cost. And so hardware emulation, software emulation. So hardware emulation means it uses FPGA or dedicated emulator near real-time performance, and virtual platforms are also there, one of the types of emulations. So complete system simulation, useful for early software development, and benefits faster debugging. So we can check the errors, and performance evaluation also we can get. Hardware independent software testing is also it is possible using these emulation techniques. So now prototyping and emulation techniques. In the previous slides we have seen separately what is a prototyping technique, emulation technique. Now if you combine together, then what is that environment? Prototyping emulation environment. So popular development environments are FPGA development boards. In this case, it is having hardware as well as it can support the software. That is why it is a FPGA development board. Okay, that is one type of prototyping emulation environment. ARM development kits. We have ARM microcontroller kits. That is also it supports both the hardware and software. That is nothing but one environment. Arduino IDE, that is also one environment, Keel Microvision and MPLab XID, Xilinx Vivado, Intel Quartus Prime. So these are all prototyping emulation environments. With the help of these environments, we can create any application. If you want to change the embedded software, we can change it for any required applications. So there are many features of this above said all the environments, popular development environments. Code development, you can develop any code. Hardware debugging is possible. Performance analysis also you can see, and simulation it supports, and real-time monitoring we can find for any applications. We can use it for any application. So now the architecture specialization techniques. So what are the architecture specializations techniques that we are seeing now? Purpose, customize processor architecture for specific applications. So based on the specific applications requirement, we can customize the architecture also. So there are several techniques for that modifications for customizations. Application specific instruction set processor, ASIPs, that is also one of the technique. System on chip is a technique for this customization of processor architectures. Multiprocessors architectures, FPGA customization, hardware accelerators. So there are several benefits of using this architecture specialization techniques. Higher performance, lower power consumption, reduced execution time, optimized resource utilization. So these are the several benefits we can achieve using these techniques, and these techniques are mainly for the purpose of customize the processor architecture for specific applications. So that is architecture specialization techniques. Now we can see system communication infrastructure, because system is there. Yes, system means we are having different development boards. So we need to ask that we need to give commands or write here some simulation code for executing or performing that hardware parts. So that is on chip communication. So that is EMBA bus, AXI bus, and wishbone bus. These are the on-chip communication related methods, communication methods. And external communication means UART and UART. That is nothing but UART and SPI, I2C, USB, CAN, and Ethernet. These are all external communication purpose. Okay. And on-chip means inside the computer, definitely inside the system. Any development board if you take, you will find these buses. And what are the objectives of this system communication infrastructure or communication methods? So fast data transfer, reliable communication, synchronization between components, and scalability. So these are the various communication methods and their objectives. So there are several applications of these prototyping and emulation techniques. There are real world applications. So automotive electronics, that is one of the real world application. For example, if you take a washing machine, that is automotive electronics, and medical devices. Recently, we have seen dishwasher, that is also a automotive electronics, and consumer electronics and industrial automation. Here, the work burden of a human being will be reduced with the help of this industrial automations. Nowadays, robotics are playing very important role in industrial applications, and robotics and IoT systems. For example, if you are having a in a room, if you take in a room or home, if you want to switch off light or fans with the help of these microcontrollers, that is possible. So that is IoT systems related. Aerospace and defense also, we are sending on a rocket or satellite to moon. That is nothing but defense or aerospace related also. We are using this concepts, embedded systems concepts. So example workflow, first requirement we see what is the application we want to design, and then we go for prototype, Then we see emulation. Emulation means required software or customized process architectures with the help of different development codes. And then we see testing, then verification, then we go for final product. So with the help of module 2, what the student can understand, he can understand the design methods, prototyping techniques for specific applications, and also you can see emulation techniques for a specific application, and he can study and he can perform on different future development environments. That is nothing but both prototyping and emulation technique environment possible. So that environment the student can easily understand. Then they can use what are the internal on-chip communication methods are there and external communication methods are there. Then after that they can go for the applications. So this is an example of workflow. First requirement, the student can understand what is the requirement of for any application, specific application, that we have to see. After that we go for prototyping, then emulating and testing, verification, then final product. If in this process, if any error is occurred in terms of design error or simulation error, we can cross check it and we can make it clear. Okay, so that is the prototyping and emulation technique of module 2 for the course hardware and software co-design. And a summary, these are the key takeaways we can take from this lecture. Prototyping helps validate embedded system designs early. Emulation enables a software testing before hardware availability, and FPGA based platforms are widely used for both prototyping and emulation. Architecture specialization improves performance and efficiency. Communication infrastructure ensures reliable interaction among the system and components. Future trends includes AI driven design, cloud simulation, and digital twins. So these are the different key takeaways from this lecture, and this is a summary of module 2, that is prototyping emulation for the course hardware and software co-design of for the MTech embedded systems program second semester. It is available for the students. And thank you everyone for listening my lecture, and if you have any queries, please contact my mail ID srinivas.nalagonda@mlritm.ac.in. Thank you very much for giving this opportunity. Have a nice day.